for this. So we are given an array of n numbers, okay, and we have to write a program in the assembly language of 8051 microcontroller. Means we have to use the instructions of the 8051 microcontroller, and using those instructions we have to write the program, and this program should be able to find out the maximum number amongst the n numbers present in that array. Okay, an array is already given to us. Now we have to assume that the length of the array, that how many numbers are present in that array, whether 10 numbers, 15, 20, 25. So how many numbers are present in that array it is stored in the register R0 of the register bank 0. Okay. Also, we have to assume that the array, because the array is stored in the memory of the microcontroller, so from which memory location the array is being stored or it is starting. So the array begins from the memory location 3000H. Okay. So the starting address from where the array is starting, it is the 3000H. Now, from that array, we have to find out that which is the maximum or the largest number. So our result will be the maximum number. So we have to store that result or the maximum number in the register R1 of register bank 0. So we have to write the program following all these things. Okay, first we have to use the instructions of 8051 microcontroller. Then we have to assume that length of the array is stored in register R0 of the register bank 0. Starting memory location address is 3000H, and we have to store the result in register R1. Okay. Now let us see that how we are going to find out the maximum number in the array. Now to find out the maximum number, we have to compare. Suppose that first of all the thing we need is the length of the array. Because we should know that how many numbers are present in that array. Suppose that the length of the array is 10. Okay, so 10 numbers are given to us, and we know that the starting address, the starting memory addresses from where the array is starting is 3000H. So from 3000H, 10 numbers are being stored. So memory addresses will be like 3000, 3001, 3002, 3003. In this way up till 3009. We will be having 10 numbers. Okay. We have assumed that there are 10 numbers in that array. After that, we will be needing some pointer. Some memory pointer will be needed, because we want that this memory pointer should point towards this starting address 3000H, and we are going to increment this pointer again and again up till this last memory location 3009. Because at all these memory location, the 10 numbers of the array, they are being stored. Okay, so we have to use a memory pointer which is incremented so that all the numbers can be compared with each other. So we will require a memory pointer. Then we will require a counter. This counter is needed because we have to count, because that there are 10 numbers in the array. Memory pointer is going to be incremented again and again so that it is pointing towards the memory addresses, and counter is needed that you have to go up till 10 memory locations. Okay, so a pointer and a counter will be needed. After that, what we will do, the first number is stored at 3000 memory location. Second number is stored at 3001 memory location. Then we will compare these two numbers. We will find out that which is the maximum number between these two. Suppose that first number is maximum is greater than the second number. So we will use one register. Suppose that A and B, two registers are used. We will move this number into A. We will move this number in B register. We are going to compare these two registers. Suppose we have find out that in the accumulator, the number is greater than the number which is in the B register. So what we will do, we will replace the contents of the A register. Sorry, in B we are having the number less than, we always want that our maximum number is in register B. So we always want that in register B we should have our maximum number. Now in register A we are having the maximum number, the first number is greater than the second number. So we are going to exchange the contents of A and B register. Now in B register we will get the first number. Okay, suppose that the first number is less than the second number, so there is no need to change the contents. In B already we are having the second number, so B will contain the second number. Now the memory pointer which is pointing towards this 3001 memory location, it will be incremented. Now it will come to 3002. Now at 3002 we are having our third number. Now, this third number will be compared with the maximum number which is in the B register. Okay. Suppose that the third number is greater than the first number, then their contents will be exchanged. Now in B we will get the maximum number which is the third number. Suppose that the third number is less than the first number, then no exchange will be done. The contents of B remain as it is. Okay. So every time we are comparing the numbers, first two numbers are compared, between them which is the maximum number, that is stored in B register. Then B and third number will be compared, whatever will be the maximum number that will be stored in register B. So in register B we are always having the maximum number. Okay. Now in the 8051 microcontroller, if we want to compare two numbers, what we are doing, every time we are comparing that which is the maximum number. Okay, so comparison is done. There can be two conditions. We are having one number in register A and second number in register B. We are comparing these two numbers. So there can be three possibilities. Either A and B, they are equal to each other, or A is greater than B, or A is less than B. When A and B they are equal to each other, it means that both the number are equal and there will be no maximum number. So we will not exchange the contents. No exchange. Now to find out that when the two numbers they are not equal to each other, there can be that A can be greater than B or A can be less than B. There can be two possibilities. Now how we will determine that which number is greater? We will check the carry flag. Okay. Now in the case of carry flag, there are two conditions, that when A is less than B, then carry is generated, and when A is greater than B, no carry is generated. So when at this step, when we are comparing the two numbers in A and B registers, we will compare that whether they are equal to each other, or A is greater than B, or A is less than B. If they are equal to each other, there is no need of doing any exchange. When A is greater than B, okay, so we want that in B register we should have our maximum number, but the contents of A are greater than B. So at that point, we are going to exchange the contents, so that in B register, we will get the maximum number. Okay. Now, when A is less than B, okay, so the number in B is greater than A, B, we are having maximum number. So here also in this case, there is no need of exchange. So first of all, we will compare that whether the two numbers are equal to each other or not equal to each other. If they are equal to each other, don't do the exchange, compare the next number. If they are not equal to each other, then check that whether the carry is generated or not generated. When no carry is generated, then exchange the contents. When carry is generated, there is no need of exchange of contents, then compare the next number. So these are the three possibilities whenever we are comparing two numbers. So this concept we are going to use in our program to find out the maximum number in an array. Okay, as I have told that first of all we have to use a memory pointer, and that memory pointer will be initialized with the starting memory address 3000H, so that the microcontroller should know that from 3000 the array of the n numbers is starting. Now we have to use a counter also, because we have to tell the microcontroller that in the array there are 10 numbers, 12 numbers, 20 numbers. So how many numbers are present in that? So we have to initialize the counter also, so that from 3000 up till 10 memory locations it is going to run. Okay. After that, we will use two registers A and B for doing the comparison, and we will check the carry flag for checking that which number is greater. So here I have explained you that what logic you have to apply to find out the maximum or the largest number in an array. Now let's see that how we are going to write the instructions in the program. What will be the steps in it? What will be our first step, then second step, so that we can get the sequence of instructions in the program. Okay. So to get the sequence, we will first draw the flowchart for this program, because with the help of flowchart, it becomes very easy to find out the direction in which the program is going to run. Okay, so sequence will also be known to us. Now in the flowchart, the first block is the start block, and this start block is always shown in an oval shape. Okay, so start, then our first step is, as I have said, that you have to first initialize a memory pointer and the counter. So first step will be initialization. Initialize the pointer and counter. Next we have to load the number, because like as I have said that the array is stored from the starting memory location 3000, then 3001, 3002. In this way all the numbers are stored. So first number should come in register B, then second number should come in register A. Then we are going to compare the two numbers. So next step is to load the data which is pointed by the pointer OP1. OP1 means that this memory pointer which is pointing at the 3000 memory location. So that data will be stored in register B. So first number we have got in our register B. After that, we will decrement our counter because first number has already been gone into register B and remaining numbers will be 9 numbers. So we have to tell the microcontroller that there are remaining 9 numbers. Now those 9 numbers are to be compared. So every time when the comparison is being done, you have to tell the microcontroller that these numbers are being compared. The remaining numbers are this. So compare them. So next step will be to decrement the counter. Now whenever we are decrementing the counter, we will check that whether the count has become 0 or not. And because this is a decision making state, so this is shown in a diamond shape. Okay. So here we will check that is the counter equals to 0 or not. So there can be two conditions, whether the counter has become 0 or not. Okay. So this condition can be yes or this condition can be no. Now when the counter is not 0, the next step will be to increment the pointer. Because first the pointer is at 3000 memory location, now the pointer has to come to 3001 memory location. So we have to increment the pointer. Now at 3001 memory location, we are having our second number. So first number is already being stored in register B. So now we have to store that second number into the register A, that is accumulator. So next step is to load the data pointed by pointer OP2. So this was OP1 and this was OP2, that is in register A. Now after that, we will do the comparison between the two numbers. One number is in register B and another number is in register A. So after that, we are going to compare that whether these two numbers OP1 is equal to OP2 or not. Okay. Again, this is a decision state, so there can be two conditions, yes or no. When they are not equal to each other, then there can be two possibilities. Whether OP1 is greater than OP2 or OP1 is less than OP2. So what we will do, we will check that whether OP2 is less than OP1. Because in OP2, that means register A, we will check that whether register A is less than register B or not. Okay. So when this condition is true, that the register A is less than register B, then we don't need to do any exchange in contents. In register B, we are already having our maximum number. So we will repeat our process. If the condition is reversed, that in register A we are having the maximum number, so we have to change the contents, exchange them. So copy OP1 to OP2 and then repeat this process. Okay. So every time we are checking if they are equal to each other, then also there is no need to do the exchange. If OP1, that is register B, is greater than register A, then also there is no need to do any exchange. If the OP1 is less than OP2, okay, then you need to do the exchanging of the contents. Then exchange the contents and repeat the process. So which process is to be repeated? This will come to again the step. Again, the data will be loaded in register B, counter is decremented, pointer is incremented, data pointer means again the number will come in register A and register B, and again the comparison will be done. So same process will be repeated again and again until this counter has become 0. So when this counter has become 0, that means this condition is true, then you are going to store the result because you have got your maximum number in register B, and then you have to stop the program. So this is the flow chart showing you that how you are going to write the instructions, what will be your first, what is the sequence of instructions, okay. So first will be the initialization, then loading of the data, then you have to decrement the counter, then you have to check that whether the counter is 0 or not, then pointer is incremented, then again the data will be loaded, then comparison is done, then the conditions will be checked, the copy of the data is to be done, and repeating of the process is also to be done. So loop is also going to be formed in the program. After that you have to store the result and end the program. So when we will write the program, what we will do, whatever blocks are there in the function in this flow chart, we are going to replace those blocks with the instructions. So it become very easy to write the program if we have drawn the flow chart. Okay. Now let's come to our program. So in the flowchart, our first block was the initialization block. That is, we have to initialize the counter also and the pointer also. Pointer is the memory pointer. We have to tell the microcontroller that the length of the array also we have to tell, and also that from 3000 memory location the array is starting. Okay. So we are going to use now, because this 3000 memory location, it is present in the external memory of the 8051 microcontroller. So to point the external memory, we are having a data pointer register. This is a 16-bit register which is called the DPTR. Okay. This is a 16-bit register which is divided into two 8-bit registers, DPH and DPL. So this, because this 3000 address, it is in the external memory, so we cannot directly access the external memory data. We have to bring that data into the internal memory, then only we can do the operations on that data. So what we will do, this 3000 memory location, it will be pointed out by the memory pointer DPTR. Again and again we are going to increment this memory pointer, and we are going to bring the number which is stored at this memory location. That is, our first number will be there. After that, at 3001 our second number will be there. So we are going to bring this data into the register A accumulator, because this DPTR can only copy its data into register A. It cannot copy the data into any other register. So first of all, we have to move that data into register A. Then we will move the data into register B. After that, second number will be shifted into the register A, and then we will do the comparison. Okay. So first step is to have our memory pointer. We have to initialize this memory pointer with the memory address 3000. So we will use the immediate addressing 3000 H. H means that it is in the hexadecimal notation. This sign means that we are using the immediate addressing. That means the data which is providing in the instruction, that is the immediate data. So that data is to be directly shifted into the register which is given here. So in DPTR we will get 3000. Okay. Now next, because we have to move the number which is stored at 3000 memory location into the accumulator, so we will use the next instruction, move X. The number which is in DPTR, we are having the memory address, okay, that is 3000. Now 3000 is not going to be shifted into accumulator. The number which is stored at 3000, that is to be shifted in accumulator. So we are using here the indirect addressing. Indirectly we are providing the address of the data, okay. So address is there in DPTR, you have to pick that address, and that address we are having the data, so you have to shift that data into the accumulator. Now because the DPTR, it is pointing to a memory location which is in the external memory, so here we are using this X for the external memory. Okay, here we are not using X, we are using X only here because the data which is in the DPTR, that is the memory address which is in the external memory. From external memory you have to pick the memory address. Okay, so these are that the first number it has come up in the accumulator. Now we have to shift this number into the B register. So we will write the next instruction, move the contents of A into B. A will be our source, B will be our destination. So contents of A will be copied into register B. Now again, after that, next step was to, in the flowchart you can see that one first number is being loaded into the register B, then you have to decrement the counter. Okay, so to decrement the counter we will use the instruction DJNZ, because you have to decrement also and you have to compare also. You have to decrement and you have to check also that whether the counter has become 0 or not. Okay, so we are using these two steps in one instruction only, decrement and jump when it is not 0. Okay, and what we have to decrement? The counter which is storing the length of the array. Okay, so in the question we were given, you can see that when we have seen this program statement, we were given that the length of the array is stored in register R0. So how many numbers are present in that array? That is already in register R0. That is, suppose if there are 10 numbers in the array, so 10 is already there in register R0. Okay, so counter is already being stored. You have to just decrement the counter. So you have seen that we have not initialized counter here. We have initialized only the memory pointer. Counter is already there in R0. Okay, so you have to decrement that R0 and you have to check that whether it is equal to 0 or not. If it is not equal to 0, then you have to jump to some memory location. J is for jumping and D is for decrementing, NZ is for not equal to 0. So you have to jump to some memory location. We have given a label to that memory location, L2, that we will specify later on. Now after that, you can see in the flowchart we have to increment our memory pointer. When you have checked that whether the counter is 0 or not, so when it is not equal to 0, you have to increment the pointer. Pointer is what? Memory pointer, DPTR. So we will write an instruction, increment DPTR. Okay. Now after incrementing the DPTR, you have to load the data which is pointed by the pointer into the next register, that is register A. because in B we have already got our first number. Now you have to bring the next number. Now DPTR is at 3001. So you have to bring this second number into register A. Okay. So DPTR is now 3001. At 3001 we are second number. So move that second number into accumulator. Again we are using the indirect addressing because we are not having the data in DPTR, we are having the address of that data. Okay, so take that address from DPTR. At that address we are having the data. Move that data into the accumulator, and because it is in external memory, so we are using move X. Okay, now after that, next step was to do the comparison. We will check that whether the register A and register B, they are equal to each other or not. Because in A we are having second number and in B we are having the first number of the array. So next is the comparison. Compare and jump when they are not equal to each other. What two contents A and B? Where you have to jump to some memory location which is given a label NEQ. NEQ is the label given to that. A and B has to be compared, and compare and jump. C is for comparing, J is for jumping. So C is for comparison, J is for jumping, and NE is for not equal to. So this is going to compare A and B register, and when the A and B register, they are not equal to each other, then it is going to jump to this memory location. If they are equal to each other, then it will go to the next step. Okay, and next step you can see that in the flow chart we have also compared that whether they are equal to each other. If they are not equal to each other, then it is going to jump to some memory location. If it is equal to each other, then they are going to repeat the process. Okay, so here if they are equal to each other, then we have to repeat the process. What process is to be repeated? That again we have to increment the data pointer. Again we have to load the number which is in data pointer into the register A, and then again the counter will be decremented and process will be repeated. So here we have to use that when they are equal to each other. When they are not equal to each other, it is jumping to some memory location. If they are equal to each other, then again it has to jump. So we will use a short jump instruction. Where it is going to jump, we will give a label to that memory location L3. Now L3 will be written at some address. You can see that in the flowchart also, when it is equal to each other, then you have to decrement the counter. Okay, there is no need of doing exchange because they are equal to each other, so just decrement the counter and repeat the process. So it is going to jump at this memory location. It is going to decrement the counter, increment the DPTR. Again the comparison is to be done. So L3 is written at this memory location. Okay, now when it is not equal to each other, okay, means when A and B, they are not equal to each other, then what is to be done? Either we have to check the carry flag. Okay, because I said that when A and B are compared, there can be three possibilities. A and B can be equal to each other, so at that time there is no need to do the exchange. Repeat the process. When A is greater than B, it means that you have to change the contents. If A is less than B, then there is no need of doing the exchange. So for these two conditions, you have to check the carry flag. Okay, so next is jump on carry. We will check the carry flag, that whether carry is generated or not. So carry will be generated when A is less than B. That means in this case. Okay. So in this case, in B, we will be having the maximum number. Okay, so in B, when we are having the maximum number, then there is no need of doing the exchange. So jump on L3. And L3 is what? Again, decrement the counter, increment the PTR, and repeat the process. Okay. Now, if suppose the carry is not generated, then it is going to go to the next step. And the carry is not generated in the case when in the number which is in accumulator that is greater than B. But we want that in B we will have our maximum number. But in accumulator we are having a greater number, so we have to exchange the contents. So what we will do, we will again jump to a memory location L1, and L1 is at this instruction where we are exchanging the contents of A and B. Now the number which is greater in A, that will come in register B, and then it is going to repeat the process. So L1 is given at this memory location. Okay. Now, when we have done the comparison again and again, we are checking, we are decrementing the counter. And when the counter is not equal to 0, we are incrementing it. Now, suppose that the counter has become 0. Okay. Now, counter has become 0 and maximum number is already there in register B. So what we have to do, we have to store our result in the register R1, because it is given to us in the program statement that you have to store that maximum number or result in the register R1. So after this step also, here we have to give one condition that when this R0 register or counter has become 0, then jump to some memory location. So here also we are providing a short jump instruction. S is for short and JMP is for jumping. So jump to what memory location? Suppose we have given here STP. Now STP is written here. This label is given here. Okay. Now here we will move the contents of the register B, which is having the maximum number, into register R1. Okay. After that, end the program. END. END is the last statement of every program of 8051 microcontroller. It means that we have terminated the program. It is the end, and no instruction after this will be executed by 8051. Just the result will be shown. Okay. So what we have done, whatever in blocks we have drawn in the flow chart, you can see that those blocks are being converted into the instructions. You can see, I will compare that. First, in the flow chart, our first step was to initialize the pointer and the counter. Pointer is the DPTR pointer. You can see that it is being initialized with the 3000 value, that at from 3000 memory location the numbers are stored in the memory of the microcontroller. Now this is in the external memory, so we have to bring that number from external memory into the internal registers A and B. Okay. Counter is already stored. How many numbers are there in the array? That is the length of the array, that is already stored in register R0. So no initialization is to be done here. If the user has to provide, okay, so here we will give one instruction and initialize this R0 register with that value of the array. Okay. After that, you have to load the data which is pointed by the pointer into register B. So first of all, we have shifted that number into register A, because directly in register B we cannot move that data. Okay. So first of all, we have moved that data into register A. Then register A is shifted into register B. So in register B we are having the first number. After that, we have to decrement the counter and check also that whether the counter has become 0 or not. If here we have decremented the counter and we have checked also that whether it has become equal to not 0 or equal to 0. Okay. Now when it is not equal to 0, then increment the pointer. When it is not equal to 0, then increment the pointer. Now here I have written that where it has to jump at L2 position, so we will specify this L2 at this. Okay, so it is going to jump at this increment dptr. You can see that when the counter is not equal to 0, increment the pointer. When it is not equal to 0, then jump to this and increment the pointer. When it is equal to 0, then when it is equal to 0, then you have to come to the last step where you have to store the result. So here we have provided a short jump instruction at the stop, and stop is provided where we are storing our result. Okay, so just the instructions are matching with the flow chart. You can see it. After that, when you have incremented the pointer, then you have to load the data which is pointed by the pointer into register A. So our next step is to the number which is pointed by the data pointer, that is loaded into the accumulator. Now after loading the data, you have to compare that whether they are equal to each other or not. So after that, we have done the comparison. If they are not equal to each other, you have to jump to some memory location. If they are equal to each other, you have to repeat the process. So here also, when they are equal to each other, we are repeating the process. When it is not equal to each other, then it is going to jump at this memory location, NEQ. So it will jump to this memory location. After that, it will check that whether they are whether which number is greater, either register A is greater than B or B is greater than A. So these two conditions are to be checked. So we will check the carry flag. Carry flag is checked. If carry is generated, means in register B we are having our maximum number. So just repeat the process. We are jumping at L1 and repeating the process. If we are jumping at L3 and repeating the process. If carry is not generated, then we have to exchange the contents. So we have exchanged the value, the contents of A, they are being shifted into B register. Okay, and the process is being repeated again and again. Now when the process has already been repeated, then if the counter has become 0, then store the number, maximum number in R1 and end the program. Okay, so this is the assembly language program using the instructions of 8051 microcontroller, and this program is able to find out the maximum or the largest number in an array. We are given an array of n numbers. The length of array is already stored in register R0, and we have stored the result of our program in register R1 of the register bank 0. Okay, so I hope that this program is now clear to you. Thank you.